Okay, continuing with what we have with echelon and reduced echelon forms. Okay, let's say if we're to determine if this following matrix is echelon, reduced echelon form, or neither. And okay, now we have for the first bit, okay, to be an echelon form, all non-zero rows are above any rows of all zeros. And guess what? The row that has all zeros is in the third position, and we have a non-zero row, okay, that is in the last row position. So automatically, okay, this is going to fall in the neither category. So that would be the outcome here. Now, if I modified this matrix, and just interchange the 7 and the 0. Okay. All right, so we have here, okay, so you have all non-zero rows are above any rows of all zeros. Check. Each leading entry of a row is in a column to the right of the leading entry of the row above it. Okay, so you have the leading entry, okay, so you have at 3. Next leading entry, we have at 1 still to the right. And okay, we don't have any more leading entries, but we still have the staircase pattern as we progress from a non-zero element from one row to a non-zero element in the next row. So this second bit is satisfied. And we have all entries in a column below are a leading entry are zeros only. So you got beneath the 3 we have only zeros, and beneath the 1 we have all zeros, and we have again no more leading entries. All right, so that part is satisfied. Okay, and we have the leading entry in each non-zero row is 1, and here we have 3. Okay, and so in this particular case, right, so this is going to be echelon form. And let's say that if I make yet another modification, and I change this 3 to a 1. All right, only one adjustment. Okay, so we have for this third matrix, okay, so you have, again, have the row of all zeros. We have to be the last row, so the first condition is met. Leading entry have 1. Next leading entry have 1. Okay, so that is satisfied. All entries in the column below are leading entry are zeros. So that is satisfied. So at least we have an echelon form, and the leading entry in each non-zero row is 1. So I have leading entry here is 1. Leading entry here is 1. No more leading entries. Okay, so this part is satisfied, and each leading 1 is the only non-zero entry in its column. So again, so 1 is the only non-zero elements in its column, and this one is also the only non-zero in its column. So that is satisfied. So for what we have here, this will be in reduced echelon form. Okay, let's say that for this fourth matrix, okay, to determine if we have echelon or reduced echelon or neither. Okay, so we have, okay, we don't have any exclusively zeros in any of the rows. Okay, so 1 is automatic. And we have second case, right, have each leading entry, have leading entry starting off with 1. Next row we have leading entry at 1. Next and last leading entry we have at 1. Okay, so you have case number 2 is satisfied, and you have all entries below leading entry are zeros. Okay, so have that part is satisfied, this part is satisfied, have that part to be satisfied. So this part, okay, we have also complied with, and then we have fourth case. All right, so we got at least echelon form. Now, let's see if we have reduced echelon form. Leading entry in each non-zero row is 1. So I had the leading entry at 1. Leading entry here is at 1. Leading entry again we have at 1. So this part is met. Okay, now to be a reduced echelon form, we had that each leading one is the only non-zero entry in its column. Okay. So we have so far, first column, this is good. This is good. However, in the case of what we have with the third and last leading entry, notice that we have another one here. And so this fifth requirement, okay, is not satisfied. And since we had the first three requirements met, but not all 5, okay, this particular item, okay, this is going to be in echelon form. All right, and just with the slightest modifications, just doing a little bit of clarifying. So I changed this up, going from 1 to a 0. And again, just kind of playing with this again. So, all right. So again, we have no all 0 rows. And again, have leading entry. Have these ones, once again, satisfied. All entries in a column below the leading entry are 0s. So have those to be satisfied, once again. Leading entry in each non-zero row, okay, is going to be at 1. So going row by row. Had to be at 1, so that is satisfied. And each leading one is the only non-zero entry in its column. And I'll stress that, in its column. Okay, so we have, so this part is satisfied, check. Next leading entry, the 1, okay, you have everything else is 0, check. And then we have with our third leading element, okay, again, before we had a 1 in the first row, and so that prevented, okay, reduced echelon form, but here we have this one is the only non-zero value in its column, and the only one for that matter. And so we have that to be checked off, and so this particular matrix is going to be in reduced echelon form.